So we'll start with the chemical methods of disinfection. In the previous video, we have seen the physical methods, that is boiling of water and UV treatment. So in the chemical methods, the first one is excess line treatment. So if you remember, in the physical methods, we have written a note here. So this, most of the microorganisms, they survive up to 37 degrees Celsius. Okay. However, there are certain microorganisms that can even survive up to 60 degrees Celsius, and these microorganisms are called as thermal resistant microorganisms. Okay. But temperature greater than 60 degrees Celsius, almost all the microorganisms get destroyed. So along with this, there is one more point that you write it here. So this is about the microorganisms and the pH level. So if the pH of the water, if the pH of the water is greater than 8.5, if the pH of water is greater than 8.5, then 99.9% of microorganisms gets destroyed. Okay. So to increase the pH, that is, if we increase the pH of water, then automatically the microorganisms or the disease causing microorganisms, that we call it as pathogens, they will get destroyed. So that is what we'll be doing in this chemical methods. So chemical methods, and in this the first one is excess line treatment. Excess line treatment. So the microorganisms are sensitive to pH. We have already written the note about this. Microorganisms are sensitive to pH. Okay. Their growth is maximum. Their growth is maximum at pH equal to 7. As pH increases, as pH increases, there is destruction of microorganism. So microorganisms gets destroyed at an pH greater than 8.5. 99.9% of microorganisms gets destroyed. Gets destroyed. So 99.9% of microorganisms gets destroyed. So this addition of lime increases the pH of lime, pH of water. So by adding excess lime, pH of water, increases. Okay. So what will happen if the pH will increase? Microorganisms will get destroyed. Okay. Now, so but along with this excess lime, so this excess lime causes some milkiness to the water. Okay. So as it is causing some milkiness, so we are not generally using this in our regular water treatment. Excess lime produces milkiness in water. It is objectionable. It is objectionable to the consumer. Okay, so such milky opaqueness what we are seeing in the water, so that is generally objectionable, so we are not using this excess lime treatment. Okay, so to remove that milkiness, we can go for a recarbonation of water. To remove this milky opaqueness we can go for a recarbonation of water. Okay, so if we do this process, then we can do it, but as you can see that we have to do these 2 to 3 processes, so we won't be going with this method. Okay, now the second one is treatment with metal ions. So treatment with metal ions. So silver and copper, so silver and copper, they have germicidal properties. Okay, so they have germicidal properties. So among silver and copper, silver has more germicidal properties than copper. That is, silver is more powerful than copper. Now the treatment with silver, we can say the treatment of water with silver. So this process has given or has been given a certain name. So that is important to us. So that it is called as electrocatadine process. So this can be asked. So the treatment of water with silver, this is called as electrocatadine process. Now the next one is treatment with KMNO4. Treatment with KMNO4. So this KMNO4, this is the powerful oxidant and it is the cheapest among all the chemicals that we use. The only thing about this KMNO4 is that it takes a lot of time to treat the water, that is to kill the microorganisms. So the time taken by it is about 24 hours to 48 hours, that is 1 to 2 days it takes for the treatment. So as it used the lot amount of time, so we don't use this in the bulk water treatment. However, this KMNO4 is widely used in the villages. So you must have seen in the wells which are present in villages, so there is some pinkish color. So that is due to this addition of KMNO4. So in most of the villages they add this KMNO4 to the wells and they keep it for 2 to 3 days and after that they use the water. So this is a powerful oxidant, so it oxidizes any substance which is present including the microorganisms. So same points we'll write here. So KMNO4 is a powerful oxidant. It oxidizes any substance. It oxidizes any substance including microorganism, but time taken is very, or we can say it is the process takes, but the overall process is very slow. So how much time it takes? It takes around 24 hours to 48 hours. So 1 to 2 days it takes it. Okay, so as it is taking a lot of time, it is not used in bulk water treatment. So where it is used? It is used in rural areas, especially in the wells. Now the next method, it is treatment with ozone. Treatment with ozone. So in most of the foreign countries, this method is used. So disinfection by using the ozone is called as ozonization, and in most of the countries except India, this method is widely used. So what ozone does is, ozone destroys the organisms instantly. So the microorganisms are destroyed instantly, and it has very little residual power. So let's write it down. So the disinfection of water with ozone, disinfection of water with ozone is called as ozonization. Ozonization. Okay. So ozone destroys microorganisms microorganisms instantly. So we have seen in the KMNO4, that is the previous chemical, so it was taking 24 hours to 48 hours to destroy the microorganisms completely. However, the ozone destroys it instantly. This ozone has very little residual powers. Very little residual powers. So let's write down the equation. There are few equations in this. So ozone O3 plus H2O. So this gives us 2HO2, and ozone plus HO2. So this gives us 2O2 plus HO. Okay. So in this HO2 and HO produced in water, HO2 and HO. So these two compounds which are produced in water together are called as, so they are called as hydroxyl free radicals. So they are called as hydroxyl free radicals. Okay, so what are the hydroxyl free radicals? HO2 and HO. So this HO2 and HO, these are powerful oxidants. HO2 and HO are powerful oxidants, and these are primarily responsible for disinfection of water. Okay, so these are all the points about treatment with ozone. Now we'll be seeing the last method and the most important one, that is the treatment with halogen group of chemicals. Treatment with halogen group of chemicals. Okay, so in this there are three halogen compounds that we are using. It is iodine, then bromine and chlorine. Okay, so this iodine and bromine, these are available only in the form of tablets. So these are available in form of tablets, and this chlorine is available in the form of powder. So we can even add the powder to the water during this disinfection process, or we can mix that powder with the water and supply that water to the main disinfection channel. Now this chlorine has very high residual powers, and hence it is used in the bulk water treatment. So disinfection of water with chlorine is called as chlorination, and it is very economical and it has extraordinary high residual powers. Okay, as it is very economical, it is best to use in India. So let's write it down. So chlorine is widely used in bulk water treatment. Chlorine is widely used in bulk water treatment. Disinfection of water. Disinfection of water using chlorine is called chlorination. It is called as chlorination. Chlorine has extraordinary residual powers, or we can say it has very high residual powers, and it is very economical, and it is very economical. So it is faster than the action of KMNO4 but slower than ozone. So it reacts faster than KMNO4 but slower than ozone. So how much time it takes? It takes about 20 minutes to 30 minutes. That is, in half an hour the chlorine will do its job. Now there is one equation, so that we have to write it. So chlorine, when it is added in water, so it gives us hypochlorite plus hydrochloride. This equation is called as hydrolyzation. Now this HOCl, it dissociates into H plus ion plus OCl minus ion, and this is called as ionization process. Now, so if we write the formula for ionization constant, this K is equal to H plus into OCl minus divided by concentration of HOCl. So if we can rearrange it, it will be like this: OCl minus divided by HOCl is equal to K divided by H plus. So from this we can say that H plus is directly proportional to HOCl. So our main equation is this. From this only everything is derived. We even know the pH is inversely proportional to H plus concentration. So we can write that H plus is inversely proportional to pH. Now the concentration, we have to write some other formulas also. Concentration of HOCl in water. So how to calculate that? So the first is percentage HOCl is equal to, how to calculate percentage HOCl? the amount of HOCl divided by HOCl plus HOCl plus OCl minus, as it is percentage multiplied by 100. We can even write this formula HOCl is equal to, if you divide this by HOCl, then what you will get in the numerator, HOCl divided by HOCl is 1, HOCl divided by HOCl is 1 plus OCl minus divided by HOCl into 100. Again this formula, you can just replace this OCl minus by HOCl, OCl minus by HOCl by K plus H plus. So this is percentage HOCl is equal to 1 divided by 1 plus K by H plus, 1 by K plus H plus into 100. So these are the various formulas that can be used for calculation of percentage of HOCl. Now once we get the percentage of HOCl, the next formula is concentration, that is how much is the concentration of HOCl. So this is equal to chlorine dose into percentage HOCl. Chlorine dose into percentage HOCl, and this percentage HOCl we can calculate by these formulas. Okay, so there is one thing about this dose. So what is the meaning of dose? So dose means what is the total amount we have to apply in water. So dose is equal to demand plus residual. That means whatever is the demand required for the complete chlorination and some residual power that is required, so this total will be equal to the dose of chlorine. So in formula wise we can write it as chlorine dose is equal to chlorine demand plus residual chlorine Now what is the meaning of this chlorine demand? See, initially when the chlorine is added to the water, it reacts with iron and manganese. After that it reacts with ammonia, and after these two processes, at the last it reacts with the microorganisms and destroy them. So in this process, that is reacting with iron and manganese and then ammonia and then finally killing the microorganisms, there is certain amount of chlorine that is consumed. So that amount of chlorine which is consumed in these three processes is called as chlorine demand. Now other than this, there should be some extra chlorine that should be present in the water, which should provide some residual powers against future contamination of water, and that chlorine is called as residual chlorine. So we have to take into consideration both this amount of chlorines. If we add them, we will get the amount of chlorine dose, and this chlorine dose then should be added during the treatment so as to meet all the demand and the residual powers. Okay, so that's it with this treatment with halogen of chemicals. Now in the next video we'll see what are the various forms of chlorine, that is sodium hypochlorite, bleaching powder, and some problems related to it.